Hello guys, this is another tutorial from Codeworks. In this tutorial, I thought of discussing Radix sort. Now, Radix sort has one of the best time complexity among other sorting algorithms. The time it's a linear time sorting algorithm, something like this. O as a function of n means it has a big O time complexity of on. Merge sort or other sorts such as insertion sort, no, it's not insertion sort, insertion sort, merge sort and quick sort. These are comparison based sorting algorithms, but this one is not a comparison based sorting algorithm, and hence it has a good time complexity. Now, this Radix sort had been used uh, in card sorting machines in the earlier days. Nowadays, these card sorting machines are not available. These can only be found in some computer museums. Now, Radix sort solves the array counterintuitively, which means by sorting on least significant digit first and then proceeding to the most significant digit. Let's consider number 456. Now 6 is the least significant digit and 4 is the most significant digit. This algorithm works by first sorting all of the numbers in the array based on this least significant digit. Suppose another number is 89, then it would sort the array based on the unit place, that's least significant digit, and then it will sort the least significant digit in the first call of the function, in that means in the first pass, and the subsequent pass it will move on to the next digit, means 8 and 5. It will sort based on the second digits and then on the third digit, but here it's nothing, so it's 0. It's 4 here and 0 here. It would sort based on this third digit. Now that's the most significant digit. This algorithm continues till the entire array is sorted um, based on all the digits of the array. Um, Actually, as you can figure out by this time, that the more the number of digits in a number, the more the number of passes. Suppose a number say x, where x can have any value from 0 to 9, as we are considering decimal numbers. Now, um, suppose this number has d number of digits in it, so number of passes of this array would be d passes. And okay, we have to suppose we have to consider that this number x is the biggest number in the array. Then if it has d number of digits, then the number of times this uh, function would call itself. um, um, I'm sorry, it's not like the function is calling itself. It's not a recursive function. Please pardon me for that. It means the number of times the sorting would take place, means the number of passes of the sort. It's not a recursive function. Merge sort is a recursive function, as I have discussed in one of my earlier tutorials, but this is not a recursive function. Anyways, the number of passes I meant. If there are d elements, the number of passes would be d. In d number of passes, the entire array would be sorted. Now, this sorting algorithm has two parts, as you can see. It's like the number of times the array would be tried to get sorted. By that I mean this d, the greater the value of d, the number of times the sorting would take place. If d is 4, the number of times the sorting procedure would take place is 4. If d is 5, it will take place 5 times, and so on and so forth. Now, what I mean to say is, suppose there's a number 425. What this happens is, 425, then suppose 23, then suppose 12. I'm not very good at drawing with my mouse, so please pardon me for this as well. So first, the sorting algorithm would consider the LSB in all the cases. Then it would get sorted based. The array would get sorted based on this LSB. Now, Radix sort tells us to sort based on this LSB, but it does not tell us what sorting algorithm we use. We can use any sorting algorithms to sort the array based on this LSB. This I should repeat. Merge, I'm sorry, it's Radix sort. Radix sort does not tell us which sorting algorithm we should use to sort this array based on this LSB. We can use any sorting array, any sorting procedure. By this I mean, wait, I think I should give you two examples of sorting procedures we can use. Actually, we can use any sorting procedure. Only requirement is that it has to be stable. Stable sorting algorithm. This is stable sorting algorithm. This is the only requirement. Okay, let me clear this. Okay, let me clear this as well. Okay. Let's suppose some of the elements of the array are, yes, the elements of the array are 0, 3, 2, or wait, let me try in this way: 5, 10, 2, 1, 3, 4. Suppose the elements are in this order. It's 4. This is nothing. This is my array. Now here in this array, only one element is a 2-digit number. The rest are all 1-digit numbers. So first, the sorting would take place based on the LSB, this 5, 0, 2, 1, 3, 4, and you can use any sorting method. In this case, I'm going to show you two actually. They are, suppose the first one is, there's a linked list here. This is 0, then 1, then 2, then 3, all the way up to 9. We're considering decimal numbers here, and the number of possible numbers in decimal is 10. from 0 to 9. If it was binary, then it would be only 0 and 1. Octal, then 0 to 7. Hexadecimal, it would be 0 to 15. Now what to do is this 5, 10, 2, 1, 3, 4. We would proceed in this manner. Suppose let's take the first element 5. 5 mod 10. Actually 5 divided by 1 mod 10, it's 5 equal to 5. So at the fifth linked list, at the fifth position here in this part, 5 would get added here. Then 10, 10 mod 10 is 0, so 10 would come here. Then 2 mod 10 is 2, so 2 would come here. Same with 1, 3 and 4. It would come here as 1, 3, 3 and 4. This is in the first pass. In the second pass, here it's 0 here, it's 1 here, it's again 0 here, it's 0 here, 0 here, and it's 0 here. It's a 0 now. Okay. Now what would happen is, suppose any of the numbers here, suppose 0, 5, so 5 by 10. In the first pass it was 1, now it's 10. 5 by 10 means 0. It's 0.5, but 0.5 in computers, in C actually 0.5 is rounded down to 0, so it's 0, and 0 mod 10 is 0, so it will be 0 here. The 0th position means, actually now all this should be erased. Wait, all this will be erased here. Okay, so 5 would come here, then for 10, 10 by 10 is 10 divided by 10 equal to 1, 1 mod 10 equal to 1, so at the ones column here 10 would come here, then all the other elements would come here in this manner, 2, then 3, then 4, in this manner, however it is. So this is one of the methods. In this tutorial I'm not going to discuss this. I'm saying this means I discussed it here to show you that there can be many possibilities, many possible ways how this sorting can be done. Okay, let's erase all this. Okay, let me just draw the audio again. It's 5, 10, 2, 1, 3, 4. 5, 10, 2, 1, 3, 4. Now the method which I am going to use in my program here is wait, it's count sort. Now what this count sort does is, it's not going to actually use the count sort algorithm, count sort sorting algorithm. It's going to modify it a bit and then use it. Okay, how this works? As is decimal, so there are 10 elements from 0 to 9. 1 2 3 4 5 6 7 8 9 10. 0 1 2 3 4 5 6 7 8 9. All 9 digits in decimal number system. The 10 array elements, and the from 0 to 9 integers. I'm sorry of this noise pollution. There's a dog down the street there and it keeps barking all the time. Sorry for the disturbance. Now, what I have to do is how this algorithm works. We have to find in these numbers the occurrence of the concerned bit. If it's the LSB, least significant bit, means the first time, means the first pass, it's 5, then 0, then 2, then 1, 3, 4. The number of occurrences of these numbers we have to find. So 5 occurs 1, so it's 1 here. 10 means ls least significant digit is 0, so 1 here. And 2, it occurs 1, 1 it occurs 1, 3 it occurs 1, 4 it occurs 1. So these digits occur only once, and suppose another digit 4, then 4 would occur twice. Another digit say 2, and 2 would occur twice here. Now we have to construct another array. I love my drawings. Okay, move a proper array here. 1 2 3 4 5 6 3 4 5 6 7 8 9 10. Okay, what this array would hold is, actually you gotta concentrate now. What I'm going to say is important. It's not very obvious, so you gotta pay attention now. But this array would hold is the number of elements less than or equal to the concerned number. If it's 0, the number of elements less than or equal to 0 is 1, so we write 1 here. The number of elements less than or equal to 1 is 2, 1 for 0 and the for 1, so it's 2 here. The number of elements less than or equal to 2 is 3, 0, 1, 2. For 0 I mean the 10. 10 more 10 becomes 0, so it's 0 means 1, then 2. There are 3 numbers which are less. There are 3 numbers which are less than or equal to 2, so 3 here. Similarly 4 here, then 5 here. There are 5 numbers which are less than 5, but suppose we consider these 2 additional elements, then 4, then there are 2 numbers in 4 and 2 numbers in 2. Then the number of elements less than or equal to 2 becomes 2, 3, 4. So it would be 4 here. The number of elements less than or equal to 3, it becomes 2 plus 1 3 plus 1 4 plus 1 5. So it would be 5 here. And number of elements which are less than or equal to 5, it would be 2 3 4 5 6 7 and 1 8. So it will be 8 here. Did I make a mistake? 0 1 1 2 for 2, just 2 here, then 2 4, then 5. Okay, 5. Yeah, for 4 it's 2 4 5 6 7. It's not 8, it's 7. And for 5 it's 8, because 1 2 plus 2 4 5 6 7 8. There are 8 numbers less than or equal to 5. The number of elements less than or equal to 6 is again 8, because number of elements whose LSB 6 is 0, same with 7 8 9. So 0 0 0. So the number of elements less than equal to 5 is 8. So 8 plus 0 is 0, then it would continue 8 8. So this is done here. Now what we have to do next is we have to find the correct position of these elements. The number of elements in the initial array is this, suppose 5 10 2 1 3 4 4 2. So 1 2 3 4 5 6 7 8. There are 8 elements here. 2 3 4 1 2 3 4 5 6 1 2 3 4 5 6 7 8. Okay. Now 5 by 1 mod 10 means it's 5 here, 5. So if you find this 5 in this array, 2 3 4 5 here, this array, okay, it's 7 here, as you can see. It's not 8, this is not here, it's 7 here. Okay, 7. So it's 7 minus 1 6, sixth index, 0 1 2 3 4 5 6. So 5 would come here. Similarly, next is 10. 10 divided by I mod 10 means 0, and so this is 0th position. Here the value is 1 minus 1 0. So at the 0th position the final array, it will come here 10. Now if you mentally sort it, we understand that 10 should come here in last position, 5 would come here. Don't worry about it, it would get sorted at the following passes, but at this stage 10 is here and 5 is here. 5 is in its correct position, no problem with 5, but 10 will get sorted later. Similarly with 2, 2 here, 0 and 2 here, 4, 4 minus 1 3, 0 1 2 3 here. 2 would come. Okay, there are two values of 2. So actually let's write the sorted array here first. 1 2 2 3 4 4 5 10. As you can see here, 0 1 2 3, 0 1 0 1 2 3, 1 2 here, 3 2. Okay, this is this, it's always it's coming to its proper place. Don't worry about this 10 after a few passes. I don't know at which pass, but yeah, it's the second pass, because it's 10, it's the biggest element, so number of passes would be 1 2. D equal to 2, so number of passes will be 2. So at the second pass 10 would come to its correct place here. then it's 1 here, uh, well, 1 here, it's 2, 2 minus 1 is 1, 0 here, 1, 1 would come here. It's 3, 3 means 0, 1, 2, 3, 3 is this one. 5, 5 minus 1, 4, 0, 1, 2, 3, 4, so 3 would come here. As you can see, first element 1 here, and this 3 here is coming to its proper position. Then 4, 0, 1, 2, 3, 4, it's 7 here, and 7 minus 1, 6, 0, 1, 2, 3, 4, 5, 6. What is this? How did this happen? How is 5 come here? 5 should have been 0, 1, 2, 3, 4, 5, 8. 8 minus 1, 7. Should be 7 here. 0, 1, 2, 3, 4, 5, 6, 7. Okay, 5 should come here. I'm so sorry. 5 would come here, and 4 would come here. I'm so sorry about this. 4 would come here. Okay, then another 4 is there. So okay, after 4 comes here, this will be decremented by 1. It would be okay, 7 there. Now it should be 6. So 6 minus 1, 5, 0, 1, 2, 3, 4, 5. Then 4 would come here. See, 4 is 4. It's coming to the proper position here. Then there's 2 here. As you can guess, 2 would come here. So this is the basic algorithm. And the second step, this would get sorted, and this, I mean, this would come to its proper position here. This center thing will shift here a bit, and this would come here. So this is it. This is the planning of this Radix sort. I admit this diagram is not so clear, but I hope I could explain you the basics of it, and I hope it helped you actually. Okay, let me write a few points here um, about this Radix sort. It's used in sorting machine. Sorting machine. I keep spelling it as shorting. It's not shorting, it's sorting. Sorry about that. It's in sorting machine. It solves in counterintuitively. It sorts counterintuitively. Counter intuitively. Okay, then its time complexity is big O d into n plus k. Okay, now this d is the number of elements, or sorry, the number of digits of the biggest number. N is the number of elements, k is the number of possibilities. So it sorts more or less in a linear time, row subscript n, and this is it actually. This is the basic planning of Radix sort. What is Radix sort, how it works. So this is it actually. This is how Radix sort works. Machine, some space here. Okay, this is how Radix sort works, the basic principle and the algorithm. Just keep in mind that it follows the process as it takes into consideration the digits from the least significant position to the most significant position, one at a time of each digit, and then sorts them in a manner so that the sorting algorithm is stable and it sorts it properly actually. And this sorting algorithm can be any sorting algorithm. um, in my case, I'm using this particular one as I showed you. It can be anything which fits actually any stable sorting algorithm. And in my next tutorial I'm going to code this in C. I'm going to use code blocks. And if you like this tutorial, do hit like and do subscribe for more such videos like this. And I'm also going to make a course on basic C principles, the C programming language, the basics actually. It's going to cover a lot of details, like it's even going to talk about the return type of printf function and things like that. So do subscribe for these videos. It will be updated soon, uploaded soon rather. And thank you.